Good evening. So in today's class, we'll be taking up an important topic from class 10 chapter Chemical Reactions and Equations, which is redox reactions. This is the whole chapter in class 11, but we'll be restricting to a bare minimum level of class 10, which is again used in class 11 for redox reactions. So let us begin. Redox reaction again is a type of a chemical reaction in which there is a simultaneous happening. Now let us understand that redox means it is made up of two words, reduction and oxidation. Reduction and oxidation are simultaneous processes. They will always have. If one substance is getting reduced, the other one will have to get oxidized. So if we are having a reaction in which we are having reduction and oxidation simultaneously, which will always happen, one of them will happen, other will not happen, that cannot be possible. So that kind of a reaction is a redox reaction. Now this redox reaction can be a simple redox reaction, it can be a combination reaction, decomposition reaction, displacement, double displacement, disproportionation, etc. All kinds. But for redox we have special criteria to check it. How to check? For checking a redox reaction we need to check whether there is oxidation and reduction happening, for which we will try to identify the criteria. Now oxidation, from its name, oxidation can be actually explained by many ways, but the most basic way is gain of oxygen. Oxidation, gain oxygen, you get oxidized. And the next simultaneous way is remove hydrogen. Gain oxygen, remove hydrogen. Another way to learn it is gain electronegative element. When we are talking about oxygen, oxygen is an electronegative element, it's a non-metal. So oxygen is electronegative. Gain of oxygen means gain of any electronegative element. Oxygen is the symbol for it. And hydrogen is considered to be electropositive. It is considered as an alkyl, it's considered in the periodic table in the alkali metals. It has only one electron. So hence, remove electropositive. Removal of electropositive, gain of electronegative, that means gain of oxygen. Removal of electropositive is symbolized by removal of hydrogen. So any electropositive element, that means element which will lose electrons to become stable, which we call as metals, is electropositive. Electronegative is the opposite. They will gain electrons to become stable. Reduction is just the opposite. So I'll just use the opposite terms for reduction. So oxidation was gain of O2. So what is reduction going to be? Loss of O2. Remove hydrogen, so gain hydrogen. Again, just inverse of it, opposite to it. Gain electronegative. Now see, loss of O2, that means loss of electronegative elements. Remove electropositive, gain electropositive, gain of electropositive elements will be a reduction. Okay. Now just again, the easiest way to remember is oxidation will be means it is oxidized, it is gaining of oxygen. Oxygen is an electronegative element, so gain of oxygen means gain of electronegative element. Now the contrary to this is, if I gain electronegative, if I remove electropositive, then also it will be possible. Electropositive is symbolized by hydrogen, so removal of hydrogen, that means electropositive element will be oxidation. And opposite to it is reduction, that is loss of oxygen, loss of electronegative. Gain of hydrogen, that means gain of electropositive identities, is reduction. These processes are happening simultaneously. Okay, they cannot isolate. If one species in a reaction is getting oxidized, the other one has to get reduced. Okay, so on the basis of that we have four definitions. So we'll have four terms based on this. The first term is substance oxidized. Substance oxidized means the substance which has undergone oxidation. So this substance gets oxidized, oxidation. So on this substance I have done any one of the four. Reduction is opposite, so substance reduced will be in which I have done any one of the four. It is undergone reduction. Okay. Now from these two definitions only we will be able to bring about the next two definitions. And they are very, very crucial. The next definition is oxidizing agent. or an oxidant. It is oxidizing agent is also called an oxidant. What is an oxidizing agent? Which brings about oxidation. Okay, that means it brings oxidation. Now, if an oxidation and reduction are always simultaneous, if an element is bringing about oxidation, it is not itself getting oxidized, it is bringing about oxidation. That means itself, what will happen to it? It will get reduced. It is reduced. As it is bringing about oxidation, it itself will get reduced. That means, I'll explain you that's why reaction, you will understand that. Let me take up the last term first. Reducing agent or reductant. This will bring about reduction, agent to bring about reduction. And if it brings about reduction itself, what will happen to it? It is oxidized. So that means in simple terms I can say the substance which is oxidized in a reaction is the reducing agent, and the substance which is reduced in a reaction is an oxidizing agent. Is the simpler way in which we can understand this. Let me take up a reaction from the NCERT. Copper plus oxygen, I'm balancing the equation, will give copper oxide. Okay, this is black in color, copper is not black. So this can be asked as an observation also, that when copper is kept open in air, in presence of oxygen, it turns into black. Why? Because it is forming copper oxide. That's a reasoning question. Now in this particular reaction, I have to identify these four substances. Now see, if I talk about copper, copper has gained the oxygen, isn't it? This oxygen has given its one oxygen to copper, and copper has gained the oxygen. So what has copper gone? It is the substance oxidized. Because copper has been gaining oxygen is oxidation. If one has oxidized, the second one will automatically get reduced. Oxygen gets reduced. Now, this is something very funny here, that we will say that how will oxygen get reduced? Oxygen ko to kuch hua hi nahi reaction mein. But the simplest thing to understand is, am I seeing this oxygen alone? This oxygen has given away its oxygens to copper. So उसने भी तो loss of oxygen experience किया है. So it is substance reduced. Okay. So this oxygen alone, oxygen is not there. Where is it? It's gone. It has given its oxygen to copper. So itself it has lost oxygen. The alone oxygen has lost it to give it to copper. So it's got reduced. Substance oxidized is the reducing agent. Substance reduced is the oxidizing agent. Now again, understanding it. Copper has brought about reduction, because copper has tempted this oxygen to give its oxygen to copper, and hence it has brought about reduction, but itself copper gets oxidized. So it is the reducing agent. Oxygen has got reduced because it's given away its oxygen. The alone oxygen is no more existing. It's formed a compound of copper oxide. This identity is lost. This is oxidized. So this oxygen which has been reduced, it is bringing about oxidation, because of this oxygen only the copper gets oxidized. So it has tempted oxidation to happen in this reaction, but itself it has got reduced. So it is the oxidizing agent which itself gets reduced. Clear? So hence substance oxidized will be the substance on which these four things I have done, any one of them. Substance reduced, the substance on which I have done any one of these four. Oxidizing agent is a substance which is itself reduced, but it will bring about oxidation. It will give the oxygen for oxidation, as in the case of oxygen here. Reducing agent, it is the reagent which is bringing about reduction, but itself will get oxidized. Oxidizing agent will bring about oxygen, itself get reduced. Okay. So hence the substance oxidized is the reducing agent, and the substance reduced is the oxidizing agent. Reducing agent is also called reductant, and oxidizing agent is called oxidant. Sometimes if I use a term antioxidants, so antioxidant is a reductant. Okay, because oxidation and reduction are simultaneous, number one, that's why the reactions are called redox. And number two is that whenever I am talking about oxidation, reduction is absolutely opposite to it, and that's why they are complementary to each other. They will always happen together. Fine. So I hope the concept is clear. In many such equations, just try to look at these conditions. You will be able to identify all the types of elements in the reaction very well. Just try to find out the condition. Okay. So with this, I hope it is clear, and we close the class about redox reactions. Thank you. Take care.